Let's find the step response of h of t is equal to t into u of t. We find the step response of the signal with s of t formula. As the given signal is continuous time signal, so let's write s of t. So the integration from minus infinity to t h of tau d tau is the formula. Here h of t is given. Now this h of t we can convert it into, no need to draw the signal, just we can convert it into h of tau signal. This h of tau is equal to tau into u of tau. Tau into u of tau it is. Now let's substitute and find the step response of the signal. So the thing is minus infinity to t as it is, this tau and u of tau. When the u of tau is there in our equation, it indicates that the signal range is from 0 onwards. So before 0 the value is 0. So or if we are drawing roughly, the signal is this one, t into u of t or tau into u of tau signal is in this way. Let's draw tau signal. It is this signal. It is a ramp signal. It is h of tau signal. The signal exists from 0 onwards up till infinity. But as we are finding the step response, it is nothing but the convolution of this h of t with the unit step signal. So the value, this integration, now no need to consider those h of t minus tau and all, as long as step response is concerned. Now let's put the lower limit as 0 because we have u of tau. U of tau starts from 0, 0, 1, 2 and so on till infinity it will be running. So 0 to t will be our limit, and this tau, no need to write this u of tau, of course d of tau should be that. So tau d tau, and the integration of this is equal to the integration of this one, tau square divided by 2. Integration of t is t square by 2, the same it is 0 to t. And when we solve this, it becomes tau square is nothing but t square by 2. So t square by 2 is the step response of the t into u of t given signal. So we can draw the signal also. T square by 2 would be this kind. Now as long as step response is concerned, no need to draw, just for understanding let me draw. T square by 2 would be this kind of a signal which takes, for t this is s of t, s of t signal, and this is true for t greater than, this answer is there for t greater than or equal to 0. So from 0 to t, so as long as our t is greater than or equal to 0, this answer is acceptable. So from 0 onwards it is existing, and the value taken, let's take this is our s of t. When t is 1, the value taken by s of t is 1 by 2, because 1 square is 1, 1 by 2. When t is 1, its value will be 1 by 2. In this way it goes on taking those values. So this will be the nature, maybe this bit flatter we get. When t is 0, its value is 0. When t is 1, its value is 1 by 2. When t is 2, its value is 4 by 2. So in this way the signal would be there. So this is our step response. Now let's see the step response of another signal. Now let's find the step response of the signal h of t is equal to e raised to magnitude of t. It is an important problem. Then e raised to magnitude of t, as we are known with the magnitudal signals, the signal looks in this way. E raised to magnitude of t signal is drawn in this fashion. Let's say this is t, or we need to change it as star. Let's do it later. So let's draw the signal h of t. The h of t is this way, and e raised to the magnitude of, let's consider e raised to minus of magnitude of t signal. We'll consider e raised to just positive magnitude of t also, the positive one. Let's solve this problem and we can go for that. So e raised to minus of magnitude of t signal is an even signal, we know. But here, to solve this problem, we need to know a little bit extra with this. We know that this signal, so h of t is e raised to minus of magnitude of t. So it's an even signal, as we know. But to solve this one, we need to know a little bit extra. So what is that? If we are, let's say, think that if we are drawing in this problem, we need to split this the signal into two sections, because we need to integrate it for the value of t. That is, we know that by substituting the values of t as 1, 2 and all, we are getting this values, this signal. And even when we substitute minus 1, minus 2, the same values we are getting. Now, but what is the value of this signal? What this exactly represents? Now, in the step response, we need to consider the signal as the combination of two signals. Suppose if we are drawing e raised to minus t signal. Suppose if we are drawing e raised to minus t signal, what kind of a signal it is? It is e raised to, if t is a 0, it is 1. If t is 1, then what is its value? It is e raised to minus 1. So e raised to minus 1 would be bit lesser than this one. So the signal would come, let's say the value is this one. When t is equal to 2, its value is e raised to minus 2. E raised to minus 2 would be again lesser than e raised to minus 1. So in this way, what I mean to say is, for t's, as t goes on increasing, this e raised to minus t signal will be in this way. But for t is equal to minus 1, what the signal becomes? This becomes when t is equal to minus 1. This e raised to, it becomes e raised to minus of minus 1. Means e raised to 1 it will be. Means its value is e1 and the value of e is greater than 1. So we may get this point. And if t is equal to minus 2, if this value of t is equal to minus 2, then we get e to the power 2. This way means a signal e raised to minus 3, if it is just without the magnitude, then it is given in this way. It is an exponential signal. Of course, it is a decaying exponential. And on the other hand, if we are drawing e raised to t signal, let's say let's consider e raised to t signal. Then what is this e raised to t signal? Just take t is equal to 0, its value will be 1. So t is increasing here. T is 1, 2, etc. And it would be minus 1, minus 2, like this on this side. If t is a 0, so if t is 1, its value would be e to the power 1. If t is 2, its value is higher. It would be greater than the earlier e to the power 1. So as t increases, its value goes on increasing. And similarly, when t is minus 1 now, when t is minus 1, then this becomes e to the power of minus 1. E to the power of minus 1 is less. And when t is minus 2, it becomes e to the power minus 2. Hence, it will be lesser. Means the signal e raised to minus t is a decaying exponential and e raised to t is a growing exponential. Now whatever this e raised to the magnitude of t is there, this e raised to magnitude of t, it may be a positive or negative. It is not a single signal, it is a mixture of two signals. So the signal is having the decaying part. The decaying part is e raised to minus t, means the right hand side of e raised to magnitude of t is nothing but e raised to minus t signal. And on this side, now the signal has the decaying again. Now it is e raised to t. It is this combination of two signals, whereas for t greater than 0, its value is given by e raised to minus t, and for t less than 0, its value is given by e raised to just t. This has to be considered before solving this problem. Now let's go for solving this. The step response s of t has to be calculated, and it is the integration from minus infinity to t h of tau d tau. It would be minus infinity to t h of tau d tau. Here we need to solve this one in two steps, because this h of t signal or h of tau, we can write this one. It is, we can index, just we can replace t with tau, and the same signal can be referred as h of tau signal. Now t can be referred as tau. Now it is our h of tau signal. So step response, as we know, it is the convolution of step signal with the given impulse signal, h of t signal, with the given h of t signal. Now h of t is this one. Here our x of t is nothing but a step. It would be by default u of t signal. Our input is by default u of t signal, which will be converted into u of tau. And then we know u of t signal, if it is represented, it will be in this way, running from 0 to infinity. And during the convolution, we know that we do time reversal, and it is our x of t minus tau signal now. It is our x of t minus tau signal, running from 0 to minus infinity. It runs from 0 to minus infinity. Now, when these two are convoluted, so when this signal is there, for t less than 0 and greater than 0 has to be considered. For previous problems, the situation was not there, because those signals were not present on the negative side, but this one is present. So we have to solve this s of t for t less than 0 as well as for t greater than 0. When t is less than 0, t is less than 0 means this signal is wherein this t is less than 0, means this x of t minus tau will be moved on the left. Let's say the situation may be this t is negative, it may be this, or even it may be in this way. Now t is negative, but what about convolution? The convolution is happening from minus infinity, because the h of tau signal is present and even x of t minus tau signal is also present. The convolution is happening from minus infinity. So from minus infinity to what value? Whatever the t we have chosen, but that value of t is negative. So whatever the equation we are writing, minus infinity to t, but this t is what? By default it is for t less than 0. And when we solve this, we get, so for t less than 0, it would be certainly minus infinity to t itself, but we know that t is less than 0. What is h of tau? H of tau is e raised to now magnitude of minus of magnitude of t, but we are not supposed to write e raised to minus of magnitude of t. we have to write whatever is the value of the signal on the left side. On the left side, the value of the signal is e raised to t. So this e raised to t, when we do indexing, like when we write h of t as h of tau, it becomes e raised to tau d tau. And the integration of this one is given by this. The solution of this becomes integration of e raised to tau is e raised to tau from minus infinity to t, and the solution is e raised to t minus e raised to minus infinity, and the value of e raised to minus infinity is 0. So the answer for this one is e raised to minus t. Similarly, for t greater than 0, we need to solve it. When t is greater than 0, s of t is given by what? Our s of t is equal to integration from minus infinity to t. Now t is greater than, or it may be equal to 0. When t is greater than or equal to 0, it is the same equation. Again, h of tau d tau. When t is greater than 0, let's see this equation. Now when t is greater than 0 means the value of the signal for t greater than 0, our t is going to be on the right side. When t is coming on the right side, then the integration has to be split. Now minus infinity to t is there, but we are coming to this value of t, or it may be even the higher value in this way. We may be coming to the right side. Then our integration has to be the minus infinity to t, but from there the value of the signal, it's not same. So we could have taken the single integration if the values were same, but we know that from minus infinity to 0, the value of our signal h of tau is e raised to tau. It is e raised to tau d tau, and from 0 onwards, from 0 to t, its value would be e raised to minus t. As the values are different, we need to take separate integrations. Otherwise, the thing could have been the same equation. Like in a single integration, we could have evaluated, but for minus reason, its value is e raised to tau, and for the plus reason, I mean for the right hand side above 0, its value is e raised to minus tau d tau. Now do the integration of these two. Now this is separate. Let's do e raised to tau. Now this becomes integration of e raised to tau is e raised to tau itself from minus infinity to 0. It is plus this one is e raised to tau itself from 0 to t. Now e raised to, we get e raised to 0 after solving this first, minus e raised to minus infinity, plus this one e raised to, it is minus tau it is supposed to be, and divided by minus 1 it is supposed to be. Then e raised to minus tau divided by minus tau it is, so this becomes e raised to minus t, and minus e raised to 0 divided by minus 1. When we solve this, e raised to 0 is 1, again e raised to 0 is 1, and this minus 1 will make this one as plus, and this is minus, and e raised to minus infinity is 0. So it is 1 minus 0 plus this all. So the answer would be, it is 1 plus 1, it is 2, minus e raised to minus t. So I hope you are getting these kind of problems. Solve the rest of the problems. So the answer for t less than 0, it is e raised to minus t, and for t greater than 0, it is 2. Greater than or equal to 0, we can write it is 2 minus e raised to minus t. We can write that in this way. For s, this s of t is equal to, it is e raised to minus t for t less than 0, and it is 2 minus, it is 2 minus, so it will be given by e raised to minus t for t less than 0, and 2 minus e raised to minus t for t greater than or equal to 0. So understand these and solve the other problems.